Let's start with the warm-up. This is what we did yesterday in class, tree diagrams. Let's say St. Louis Park and Hopkins are tied and time has run out of the game. However, Rachel has a free throw and she has 2 shots to make. She usually makes 62% of her free throw shots that she attempts, and the shots are independent. So make a diagram, a tree diagram, and calculate. Okay, so let's do that. Okay, so here's Rachel at the line. She can either make or miss. So here's that she makes it. Here's that she misses. She gets another shot, and again, she can either miss it or make it. So she misses or she makes it. Okay, so our probability, she has a 62% chance of making it. Was it 62? Yep. Better go back and check. Okay, so 62% chance of making it. 100% minus 62 is 38, so she has a 38% chance of missing. All right, let's calculate each probability here. Okay, so the first one, she makes it both times, multiply those together, we get about 38.44%. Here she makes and misses, multiply those together is 0.2356 for each of these. And 0.38 times 0.38 is 0.144. So she has about 14% chance of missing. All right, probability she misses both shots, about 14.4%. Probability she makes both shots, about 38.4%. Probability she makes at least one of the shots, at least one. So she can make both or one. We're going to add these together. Let me try that. So 0.2356 times 2 plus 0.3844. So that's about 85.56%, and that is also the probability that they win the game if they're tied. So that's what we did yesterday, tree diagrams. Today we're going to look at Venn diagrams. So first, a definition. Mutually exclusive are two outcomes or events that cannot both happen. So for example, you cannot take science and English first hour at the same time. So if you notice, you either take science or you take English or you take something else, but they don't overlap. Let's talk about probability here. What's the probability that a person takes science? A is science, and that would be 8 out of the total. And the total you're going to add 8 plus 5 plus 14, which is 27. And if you want to change that to a percentage, you can divide, and that's about 29.6%. What's the probability that they take English first hour? And that will be 5 out of 27. And you can calculate that probability. So 5 out of 27. And what's the probability that they take A and B, science and English first hour? That would be 0 out of 27. You can't take science and English at the same time. What's the probability they take science or English first hour? So or is one or the other, or both. So this one we have 8 plus 5 is 13 out of 27. So or means one or the other, or both, but here there's no both. All right, so can you think of two events that are mutually exclusive, two things that cannot happen at the same time? Okay, let's look at some things that are not mutually exclusive so they can happen at the same time. So for example, you could participate in track and you could participate in basketball because the seasons don't overlap. So if you take a look at this Venn diagram, 2 people play both sports, 10 people just do track, 8 people just do basketball. So let's figure out probability here. What's the probability that they're in track? So here's track. Track is the whole circle. So it's not just 10, it's actually 12 out of, and we add everyone together, so this is 10 plus 5, 25. What's the probability that they're in basketball? Well, here's the whole basketball thing. So that's 10 out of 25. What's the probability that they are in A and B? So and means they do both. And so that would be this overlap right here, 2 out of 25. But what's the probability that they are in A or B? Okay, so A or B means probability of A plus probability of B. So it means one or the other or both. So you're going to add all these 3 together. So we have 10 plus 10 is 20 out of 25. So or means one or the other or both. Okay, so again, or, to find the probability of A or B if they don't, if they're not, if they are mutually exclusive, would be probability of A plus probability of B. And this one right here, you add everything up, and there's some overlap here. So this is probability of A and B. This symbol means and. So this would be a probability of A, which is the whole A circle, plus the probability of B, oops, which is the whole B circle. But you've counted this overlap twice, so you subtract out the probability of A and B once. Okay, so those are the formal definitions of the general addition rule. Let's do some examples. A single die is rolled. What is the probability of rolling a 2 or a 5? And those are mutually exclusive. They're separate. You can't roll a 2 and a 5 at the same time. There's 1 out of 6 sides that are probability of a 2. And we're going to add the probability of getting a 5. So here's what it looks like. 1 6 plus 1 6, which is 2 6 or 1/3, about 33.3% chance that you're going to roll a 2 or a 5. Another example. A single card is chosen at random from a standard deck of 52 playing cards. What is the probability of choosing a king or a club? Okay, so probability of king plus the probability of a club, but we have to subtract the overlap. So if we count all the kings and all the clubs, there is one king that's a club, so we have to subtract out that one that we counted twice. We counted the king of clubs twice, so we have to subtract out the probability that it is a king and a club. Okay, so let's do that. How many kings are there in a deck of cards? There are 4 out of 52. How many clubs are there in a deck of cards? There's 13 out of 52. But we already counted one of the kings twice, so we have to subtract that 1 out of 52 that you get the king of clubs. All right, so we do that. 4 plus 13 is 17 minus 1. We get 16 out of 52, and you can get that percentage by dividing. It's about 30.8%. Next example, in a class of 30 students, 17 are boys and 13 are girls. On a unit test, 4 boys and 5 girls got an A. If a student is chosen at random, what is the probability of choosing a girl or an A student? All right, so this is probability of a girl plus probability they got an A. But we counted the girl that got A's twice. We're going to subtract out the probability of girls that got A's. So girls and A's. All right, so how many girls are there? 13 out of 30. Plus, how many A's are there? Okay, so we add up all the A's. 4 plus 5 is 9. Okay, but we double counted some kids. There are 5 girls that had an A grade, so minus 5 out of 30. So we double counted those twice, so we subtract. All right, 13 plus 9 minus 5. Oops. Okay, so our probability will be 17 out of 30. So again, you had girls here, and you got the A's here. We counted this middle part twice. So here was girls, and then here was A's. We counted that double part twice. That is what we subtract here to get our probability. And that is about 57% about. Okay, so sometimes Venn diagrams already have things as decimals. So here's an example of a certain group of kids. 25% are juniors that don't take Algebra 2. 20% are juniors that take Algebra 2. 30% are in Algebra 2 that are not juniors, and there's 25% that are not juniors and not in Algebra 2. So that's how you can describe the situation. What is the probability that you select a junior? Well, you count how many juniors are in the class, and this is already in percentages, so you just add them up. So this is 25% plus 20%, which is 45%. So 45% chance of choosing a junior. What is the probability that they are a junior or they're in advanced algebra? So here, you add up these guys, you add up these guys, subtract out the middle, or you can just add them all at once. So 25% plus 50% is 75% chance they're in junior in Algebra 2 or a junior in Algebra 2. What is the probability that they are in Algebra 2 and not a junior? Okay, so that would be this 30%. And here's this last one that's a little bit, you have to think a little bit harder. What is the probability they're a junior given they are in advanced algebra? Okay, so here's a junior given they are in advanced algebra. So let me see here. Okay, so if they're a junior given they are in advanced algebra, okay, here's how many juniors are a junior in advanced algebra. That's that 0.2. But how many are in advanced algebra 2? So here advanced algebra goes on the bottom. It's that second one. So how many are in advanced algebra? We add together the 0.2 plus 0.3, which is 0.5. So this is a 2/5 chance. So again, given, if you ever given, the thing over here goes in the bottom, the 0.5, there's 50% are in advanced algebra, and then 2 are juniors that are at 20% are in juniors that are in advanced algebra. All right, suppose there are 160 people in that Venn diagram. Change each probability into a frequency and number of students. Okay, so you multiply. So here, let's just do it from the diagram. What is 25% of 160? You just multiply to find the frequency. So 0.25 times 160. So there are 40 kids here. All right, what's 160 times 0.2? So this is 32 kids here. So all I'm doing is multiplying each of these by 160. So 160 times 30%, there's 48 kids here. And then 0.25 times 160, there are 40 kids that are not juniors in advanced algebra. Okay, so frequency, you just multiply your probabilities by your number. Okay, 2 more examples. In a class of 30, 16 students take Spanish. So let's say this is Spanish, and 6 students are in foods. 25% of the students that take Spanish are also in food. So 25%, 0.25, of the Spanish kids, so 0.25 times how many kids are in Spanish? 16. So a quarter of 16 is 4. You can figure that by multiplying, so 0.25 times 16, or a quarter of those. All right, so there are 4 kids that are in both. So start there, 4 kids in both. All right, there are 16 students in Spanish, so here's Spanish. 4 are in both. How many are left that are just in Spanish? 16 minus 4 is 12. All right, how many are in food? 6 total in foods, 4 in both, so there are 2 kids left that are in food. So now total in the food circle, you have 6. And that's all we have. Oh, in a class of 30, so let's do 30 minus 12 minus 4 minus 2. All right, there are 12 kids that don't do either. Okay, so if you have to draw a Venn diagram, start with the middle and then work your way outside. Okay, the last definition is a complement. If you have an event X, the complement consists of all the outcomes that are not X. Use a complement to find a probability. When 2-sided dice are tossed, here are the 36 outcomes. Find the probability of a given event, that the sum is not 8. Now if you take a look at this, if you count all the sums that are not 8, that's not as fast as counting how many are 8 and subtracting. So if I find how many are 8, so let's see, we have 8 here, 6, 7, here's 8. Okay, so here are all the sums that are 8. That's a lot faster than counting all the ones that are not 8. So the complement is 1 minus x, 1 minus what you're trying to look for to find the complement. So here we have 1, 2, 3, 4, 5. So if we do 36 minus 5, we have 31 out of 36. There's your probability. It is not 8. So the complement is your total minus what you're looking for. Let's find the probability the sum is greater than or equal to 4. Well, how many sums are less than 4? 1, these are less than 4. All right, there are 3 that are less than 4, so all the rest are greater than 4. So the complement is easier to use. 36 minus 3 is your complement. And then, so I should say it's your total minus x is your complement. Okay, so we have 33 outcomes out of 36 that are greater than or equal to 4, and then you could figure that probability out. All right, so today practice with your Venn diagrams, and let me know if you have any questions.